Hello everyone, welcome to pipebench.com. Today we're going to make a tutorial video to show you a quick assessment tool for your pipelines if your pipeline has encountered a recent landslide. Landslides is a very common geohazards happen to a long distance pipeline. However, a lot of the times depends on how big a landslide is. This whole industry is generally like a quick assessment tool to tell if the pipeline is safe to operate at a current pressure, or do we need a kind of like the pressure reduction, or do we need to shut down the pipeline right now for mitigations. Based on a recent research done by the industry, we have developed this really quick string assessment tool that to give people a little bit of flexibility to have a quick survey about landslides and to have a conservative approach to say this pipeline is likely okay, or we kind of need to take actions and do a more advanced assessment. Meanwhile, maybe we can consider a pressure reduction to mitigate the risk. Again, this is a very easy to use tool. Let's just dive into this in details. Like all our other tools, we do offer imperial or metric units. So for this tutorial video, we're gonna just follow the imperial units. And the first part is about the pipe data inputs. We have this same drop down menu for many of our other tools. So if you know the nominal size of the pipeline, you could quickly just select it, and based on the wall thickness, we have all this common wall thickness drop down available. If you have a pipeline that has a custom like a size or wall thickness different from the drop down menu, you could just go with custom to activate this manual inputs. So in this case, I'm going to just use a 12.75, and since the wall thickness is let's say a quarter inch, for example, right? So that's how you put in the kind of like the wall thickness and the size, not on the drop down menu. And then for the maximum pipe displacement, this is gonna be either from a LiDAR data or from a quick field survey. You recently observed a landslide event along a pipeline, and this is the maximum pipe displacement you have seen. Basically the total at the worst part of the landslide convert to your pipeline, how much the displacement is going to be. So in this case, we can just say you observe a 20-foot displacement, and the width of the ground movement is the total length of the pipeline within the landslide region. Again, this can come from LiDAR, from site pictures, or from a field survey. So in this case, we can just put a more conservative line, let's say 350 feet long. And then come down here, we have a default for the carbon steel pipe Young's modules, but you could tick here and change it to 30 KSI. Some people prefer to use 30 instead of 29. And then the selected model here, we offer multiple mathematical models that can be used for the quick assessment. And of course, in the graphs below, you could see all different curves. Each color represent to each one model. So you could tell they all kind of like say this is the pipeline profile. Basically is the maximal displacement versus total span you have seen, and this is kind of generate a generic deflected pipeline profile. So based on your real survey, you could just select the one more reflect to what you're seeing in the survey. You could, um, individually hide and show different model here. Um, just click on the graphs. Uh, or there's an easy way to do it is to select here. You could, again, if you're not sure which one, we do recommend the CRES fixed end model or Suzuki model with n equal to 3. So, like say, for example, in this case, we're going to just highlight this two here. So you can tell that we're only going to show the results of the two model. And based on the deflected pipeline profile, we get the maximum soil displacement versus the maximum total strain demand. And this is really what are you going to look at and compare it to your threshold. Most of the pipeline operators, you have a different threshold to say, for example, if it's below point 2, there's no action required. The pipeline likely is going to be okay. Just monitor the landslide, and maybe to see if the things gets worse. If it's like between point 2 and point 6, maybe it's gonna trigger some advanced assessment of the pipeline strain. Meanwhile, maybe consider lower the pressure. And if it's over 1.0, for example, it's going to trigger some line outage. We have to fix this risk immediately. You probably have to do a stress relief, activation, stuff like that. But this is really just gonna tell you, really tells you what's the calculated maximum strain demand. So for example, in this case, you have 20 foot maximal 20 foot displacement. You could potentially over 1.0 1% total strain, so which is pretty high. So if you actually see this, it's probably gonna trigger some, really more rigorous mitigation process. And also below, there's two tables you really to show the calculation method and how to, they really break down for bending strain and a membrane strain and how we add them together for that, like a total strain. Again, you could select all and show everything, so it's going to show more tables. So that's kind of like a quick rundown how we use the tool. Again, everything can be custom selected to show. Like all our other tools, we do offer more features as shown here on the button. So you could save this calculation and in the file on the cloud server. So next time if you log in, you can revisit this calculation, or you could download a copy of this calculation to your local drive, or you could open this local drive file by use the open button here. And you can also generate a PDF report. You can put in some information, and this PDF report can be shared with others or put it in your project folder. So that's kind of like a quick rundown about how to use this biorated pipeline strain assessment tool. Again, this is no intended to replace the actual comprehensive strain assessment, such as the FEA analysis. But this is to really give people a quick way to see how the pipeline is in the strain level is after a landslide. So if you have any other questions, feel free to reach out to us. So thank you so much.